So here's your next problem. It's the integral of 3dx over 25 plus 16x squared. And I went ahead and pulled out the 3 and made it into the form of a squared plus u squared. So 5 squared is 25, 4x squared is 16x squared. You can go ahead and write out a is equal to 5, u is equal to 4x, and therefore du is going to be 40x, and dx will be 1/4 du. From there, you can go, this is kind of going back to the beginning again, the integral of 3dx, 25 plus 16x squared, and then we use the u substitution, so it's going to be 3 over 1/4, because you pull out the 3 and multiply it by the 1/4 in the du, 5 squared plus u squared, which is the a squared plus u squared, and then you can plug in du, so 3/4 times 1/5 tangent inverse u over 5 plus c, and then you fill in that last u with the 4x, so and multiply out 3/4 by 1/5, so that's 3/20 tangent inverse 4x over 5 plus c. And here's one last example. So we have the integral of dx over the square root of 2x minus x squared, except this isn't in the form that you need it to use the sine inverse formula. It's 2x minus x squared versus, let's say, x squared minus 2x. But you could change this, so you can say 2x minus x squared and pull out the negative, which you would therefore have negative times, or negative 1 technically, times x squared minus 2x. And that is in the formula of the sine inverse. So therefore, you can add 1 to the front and subtract it again inside the bracket. So we're going to have 1 minus the x squared minus 2x plus 1, which therefore goes to 1 minus x minus 1 squared. Do a and u substitution, so a is going to equal 1, u is going to equal the x minus 1, du equals dx. Plug this back into the original formula. So we're going to have du, or the integral of du over the square root of 1 minus u squared, which equals the sine inverse u plus c. Then you just plug in u, sine inverse of x minus 1 plus c, and that's your final answer.